All right, let's get into it. Today, we're taking a pretty epic journey, one that starts with humanity's very first lonely beep from orbit and takes us all the way out to the incredible rings of Saturn. This is the story of how we, as a species, decided to leave our home and explore what's out there.
You know, for pretty much all of human history, the idea of going to the moon, well, it was just a dream, something for poets and storytellers. It was completely unreachable. But then, in the 20th century, something incredible happened. The unthinkable suddenly became the mission.
And what a mission it was! The space age didn't just dawn, it exploded onto the scene. It happened so fast. In 1957, you have Sputnik 1 beeping its way around the planet. Just 4 years later, Yuri Gagarin is up there. And a mere 8 years after that, we're walking on the moon. Just think about that, from the first little satellite to boots on another world in only 12 years. It's absolutely staggering. So here's our plan for today. We'll start with the ignition, that first spark. Then we'll cover our first steps into orbit and to the moon. After that, we'll look at working on the frontier, sending out our robots to other worlds, and finally, we'll talk about the journey's echoes. Let's launch.
Okay, first up, ignition. The dream of leaving Earth is as old as humanity, but it took a very specific set of circumstances, mainly the Cold War, to finally light the fuse for this incredible adventure. The actual science that turned all of this from science fiction into reality? That's astronautics. This is the field that grapples with the enormous question, how in the world do you build a machine that can just defeat gravity? Early pioneers really laid the groundwork, turning complex theories into actual powerful rockets. And those rockets basically come in two main flavors. You've got your liquid fuel rockets, which are super complex but give you a massive advantage. You can control them. You can throttle them up and down, even shut them off and restart them. Then you have solid fuel rockets, much simpler, more stable. You just light the fuse, but once it's lit, man, it is going until all the fuel is gone. There's no turning back. All right, part 2, first steps. So with the rockets figured out, it was time for the truly heroic era. Humanity's first honest-to-goodness giant leaps off the planet. So what was that first real leap? It all comes down to this number, 196 miles. That's how high Yuri Gagarin went. Now that might not sound like a lot today, but in 1961, that was the line between our world and everything else. He became the first human being to ever see our planet from space, to see the curve of the Earth.
Gagarin's flight absolutely lit a fire under the United States. Just a few weeks later, President Kennedy went before Congress and threw down the gauntlet with this incredible challenge. Put a man on the moon and bring him home safely, before the decade is out. The race was officially on.
Now to get to the moon, you couldn't just use any rocket. You needed a monster. You needed the Saturn V. Just try to picture this, a machine weighing over 6 million pounds. It was an absolute titan, the most powerful rocket ever built, and it was the only machine that could hurl us toward the moon.
Which brings us to our next section, working on the frontier. Because, just getting to space was one thing, but how do you actually live there? That's a whole different challenge.
A day in orbit is just, well, it's weird. You can't just lie down to sleep. You have to tether yourself into a sleeping bag so you don't float away. Using the bathroom requires a special suction system. And this is so important. You have to exercise for 2 hours every single day, just to fight against the muscle and bone loss that happens in microgravity.
But our presence in space has left behind a bit of a mess. For every working satellite up there, our orbit is getting clogged with junk. Old rocket parts, dead satellites, little fragments from collisions. Get this, a staggering 95% of the objects we track in low Earth orbit is just debris. It's a cosmic garbage dump, and it's a real and growing threat.
Okay, on to our next leg of the journey, robots to other worlds. While humans were learning how to live just a few hundred miles up, we started sending out our robotic emissaries to explore the places we couldn't get to yet.
Landing on another planet is one of the hardest things we do. To get a rover on Mars, for example, your spacecraft hits the atmosphere going about 10,000 miles an hour. From there, a heat shield, a massive parachute, retro rockets, and even a cocoon of airbags all have to work perfectly, in sequence, just to get the rover down in one piece. It is a nail-biting 7-minute ordeal from start to finish.
And with every new mission we send, our ability to gather information just explodes. The Cassini mission, which went to Saturn, sent back over 2,500 gigabytes of data. But look at the Mars Reconnaissance Orbiter, or MRO. It's expected to send back almost 35,000 gigabytes. The old trickle of information has turned into an absolute fire hose.
And that data has led to some truly incredible discoveries. The Galileo probe found evidence of a saltwater ocean on Jupiter's moon Europa. The Cassini-Huygens mission actually landed a probe on Saturn's moon Titan, a world with a thick atmosphere. And MRO found really compelling signs that liquid water once flowed all over the surface of Mars. I mean, every one of these missions basically rewrites our textbooks.
And that brings us to our final section, the journey's echoes. How have these voyages to the very edge of the solar system come back to affect our lives right here on Earth?
You know, maybe no mission captures this better than Voyager. These twin probes launched way back in 1977 and did this amazing grand tour of the outer planets. Today, they're the most distant objects humanity has ever created. They've actually left the bubble of our sun's influence and are now sailing through interstellar space, carrying a golden record with the sounds and images of Earth, a true message in a bottle cast into the cosmic ocean.
But the echoes of this journey aren't just out in deep space. They are literally in your house. The technology we had to invent to solve problems for space missions has this amazing way of trickling down into our everyday lives. Things like air purifiers, cordless tools, the amazing digital cameras in our phones, even advanced water filters. So many of these have their roots in the space program.
So, from a simple beep in 1957 to walking on another world and sending emissaries between the stars, we've managed to achieve things that were once considered pure fantasy. We've done the unthinkable. And that leaves us with the one big question you see here. Having done all this, where does our journey go next?